Presented to us today is 2x plus 3 times minus 5x squared, take 4x, take 2, and we want to use synthetic multiplication to expand this out. This algorithm is very similar to your rack and stack in multiplication, except it's slightly easier because you don't have to do a carry. First thing we're going to do is we're going to ask ourselves, of these two products, which one is larger?
One on the right.
One on the right. So one on the right is going to be designated as big dog. So I'm going to start off on the right hand side of my board for extra space, and I'm going to go minus 2, then I'm going to go minus 4, and then I'm going to go minus 5. Basically I'm writing all of my coefficients. Next I'm going to get the other one, and I'm going to go 3, and then I'm going to go 2. Next we gear ourselves up for multiplication. Now this is just rack and stack, except there's no carry. 3 by 2 is minus 6. 3 by minus 4 is going to be minus 12. 3 by 5 is minus 15. Then this unit is out. Next one, it's going to be 2 by minus 2, that will give us negative 4. 2 by minus 4 is negative 8. 2 by minus 5 is negative 10. Yep, negative 10. Now, we've exhausted this guy, we've exhausted this guy. It's time to sum. You have minus 6. You have negative 16, you have negative 23, and then you have negative 10. Now each of these represents a coefficient in our subsequent expression. This will be x to the 0. Actually, I'll write it next to it. X to the 0, x to the 1, x to the 2, x to the 3. Yep. So when we expand this out, we're going to find this out. We get minus 10x cubed minus 23x squared minus 16x to the 1, take 6, and we don't need to do 1. Does that seem alright? Seem like something you could do with ease, zest and vigour?
Why does this? Why do I need this?
Because
Save my class in a minute.
Okay, so that's nice and easy. It's a linear or a linear multiplied out by a quadratic, isn't it? What about if we spice it up a little?
Yeah.
Could you expand that one? And he's given it the head nod.
Yeah.
Give you guys a little head start, and then I'll start throwing the solution up. Can I get rid of the one I've done on the board?
Yeah.
Do we all get the setup okay? So whenever we have a coefficient of 0, so no representation, we put a 0 in our rack and stack.
Yes, the given.
X to the 4 secant variance u 14.
It's x to the power 5, I believe.
Right.
Mad Dog got it wrong.
My dog got a bit sick, I think.
Just get the 0 then.
What?
Just get the 0. That's gonna be 4.
Seem okay?
Yeah.
So this is called synthetic multiplication. The application of synthetic multiplication is for when you're dealing with polynomials of higher order or of a higher order than 2. So that, you're dealing with products that are of a higher order than a linear factor, because it enables you to be able to expand outwards at a much faster rate. Otherwise you have to do the FOIL, which wouldn't be cool, because you'd end up doing much more operations. You'd be like, what did we do? Like bang, bang, bang. You'd have to multiply out 6 times, and then you'd have to do all the shuffling of like terms and then the summing of the like terms. This is tidier, and you're less likely to make mistakes. Happy with that?
Yeah.
Alright, awesome. So there's not much to this other than what you've just seen with the example on the board. Sometimes you can be given algebraic expressions. Sorry, not algebraic, but what I mean is you might have a coefficient of a, b, or a plus b in there, or a plus 1 in there. You still do the same thing. When you're summing it up, you just sum it up as if it was you're collecting like terms in algebra. Is that alright? Nice.